Modern cities are wired with cameras. We see them everywhere, silently tracking crowd flow, deterring unauthorized entry, and watching out for vandalism. It is easy to look at this massive grid of lenses and assume it creates an airtight, proactive security shield across a building or a downtown district. But expanding the camera network does not proportionally increase actual security. Adding more lenses to a street corner yields diminishing returns. Camera technology is infinitely scalable. We can build and install thousands of them cheaply, but the human brain tasked with watching those feeds has strict, finite limits. Moving from the streets into the control room changes the perspective. One person sits at a desk, surrounded by a massive, overwhelming array of screens. A single person at one of these desks is often tasked with dynamically managing up to 16 complex, constantly moving camera scenes simultaneously. A surveillance system's strength depends almost entirely on the processing capacity of the human mind at its center. The intended ideal for these systems is proactive surveillance. The goal is to forecast suspicious events and analyze trends to prevent incidents before they even happen. To do this, an operator needs immense situational awareness. They must constantly interpret shifting ambient conditions, analyze the layout of an area, and judge whether a subtle change in crowd behavior looks suspicious. They also need extreme vigilance. This means maintaining sustained, effective attention across all those dynamic screens without dropping focus to process what they are seeing. Because the cognitive burden is so incredibly high, the operator's brain reaches a breaking point fast. After just 20 to 40 minutes of active monitoring, human attention simply crashes. The physiological result of this overload is a state known as video blindness. The operator loses the ability to recognize distinct objects or events happening right in front of them, even while the screens are playing. This chart visualizes field study findings on operator performance, showing that proactive monitoring successfully accounts for only 35% of overall incident detection. The rest are either missed entirely or caught through other means. Expecting humans to maintain proactive visual monitoring for hours on end is a flawed system design. It places an impossible burden on the controller and actively degrades their capabilities over time. To survive this visual overload, the human processing unit automatically reroutes to a secondary, less demanding method: reactive surveillance. Reactive surveillance is a completely passive state. Instead of constantly scanning screens for trouble, the operator waits to be notified by external auditory feedback. In 2006, researcher Paul Kevill conducted an ethnographic study of 6 CCTV public monitoring rooms in the UK to see how operators actually spend their shifts. His findings showed a shift in how operators actually use their senses. Even though the technology is visual, the monitoring task itself is audio-driven. The operator springs into action only when activated by a specific auditory trigger. This usually comes from a police radio, a company walkie-talkie, or an incoming complaint about suspicious behavior. Operators absolutely do not check every single screen continuously. The concept of an all-seeing eye watching the city at every moment is a myth. A multi-million-dollar visual surveillance network remains effectively dormant until a simple audio alarm tells the human exactly where to look. Once that auditory alarm is received, the station supervisor snaps into action. They scan the display matrix, locate the suspect, and lock onto the target. They manage a rapid series of technical inputs. They bring up secondary cameras to get different angles and utilize active panning and zooming to isolate the specific event on the screen. Simultaneously, they handle underlying equipment management. They verify the most appropriate DVR recording modes, adjust monitor contrast to pull out visual details, and ensure terminal switches are properly set. Then comes the external output phase. The operator provides real-time intelligence over the radio while dispatching police or fire services directly to the physical location. They can also deploy direct intervention tools right from the desk. If an intruder is detected, they can activate remote loudspeakers with pre-recorded police warnings to deter the suspect on site. Observational research in the London Underground further maps this complexity. The operator's true job involves handling a massive web of reactions, bouncing between passenger complaints, managing active situations, and dealing with network IT problems. The operator functions as the core of the entire control system. Ultimately, the effectiveness of the surveillance network depends on the capacity of the human mind at the center